Hello, welcome to the wonderful world of random sequencing. Also, I have another channel called Sequencing Random Numbers. That's plural, and that's my email address. I do analysis on Lotto, and I do analysis on roulette. If you happen to have any spins that you want to analyze on roulette, I could do that too. I'd like to get some of those numbers so I could analyze. I like getting them with time sequences too. So in other words, whenever those spins occur on roulette, I like to know the time because I like doing analysis on that too. So anyway, I'm going to be talking about Super Lotto Plus. As you can see right here, these are Super Lotto Plus. I don't know what you call them, spins. I call them spins because they're balls that fly up in the air. I don't know what to call them, but anyway, so to understand the concept of lottery, the spins that occur, the randomness, you got to understand what virtual numbers are. You got to understand. Well, virtual numbers are basically, they could represent themselves as big numbers or small numbers. In other words, right here, if I could find it. Let's see, 36. Let me see right here. See the 72 right here? Now, is it 72 or is it 27? Now, it plays two roles, because it could play itself as a big number like 72. In other words, 72 is equal to 36 plus 36. You see? Now, this is what you call a bridge number. These are bridge numbers. The bridge numbers are 11, 13, and 14. They help to bridge sequences. So this is what's called bridge numbers. 11, 13, and 14. This is equals. This is the I am statement. This is the I form statement. So in other words, they help leak sequences. Like the one I was just showing you right over here. Yeah, see, 72. This is 72, right? And then you have a bridge that links it, and then it creates a 36, 36. Now this is also can be seen as 72. And this says 7 twos, which is 7, 7, and 7 plus 7 is equal to 14. So you have 27, and then you have the bridge, and there's your 14. See, so that's the concept of bridge numbers right here. You also have to understand metamorphic numbers. Metamorphic numbers. Okay, let me see if I can see. Like for instance, this is a metamorphic number. This is equal to 86. See, this is 0, 0. That makes a 8, and then this number makes a 6. So what you get is 86. You see, so that's what you call a metamorphic number. Now over here you have binary numbers. This is a binary. Here's a binary number. Now this could be equal to 3 in binary notation, but over here when it links like this is what you call binary to decimal numbers. And so in other words, it's half binary. This is the two cells, right? If you get all the ones, that's 1, 1, 1. That's equal to 7. So this could represent either 14 or 27. But anyway, so those are this is what you call binary to decimal numbers. And then you get algorithms, big numbers that are that the numbers are on the right hand side to double digits numbers, like let me say 86. You see, this is what you call an algorithm. These are all algorithms. And so if you divide this number by half, you get in other words, this is 3 and 4, so 34 plus 34 is 68. So you could get a 34 34 sequence. In other words, right here you see that sequence right there. So this is like 34 34. This is a reverse sequence, but it's equal to 34 34. That's why you get this 86 here. That's the algorithm. So all you do is just basically, since they're both even numbers, right, you just divide them by half and you get the statement of 2 equals. In other words, this is 34, and 34 plus 34 is equal to 68. So this is basically what that is. This is a reverse sequence, but it still equals to this. And you get this. So you can see the frequency of occurrence here. So it's a very powerful sequence that's happening. So that's the concept of that. Now, I already told you about bridge number. So what I'm going to be talking about is how this this thing got played out right here, this sequence right here. Let me see if I could highlight it for you here. So this is the number that we're going to explain right now. Now, the way they happen, you know. Now, as you can see over here, notice how it created a 17, right? So all these numbers you see right here, they get played out. In other words, this particular cell right here, see, it's a half step away. So in other words, this sequence could be affected with this bridge, this group of numbers. Same thing with this over here, you know, these group of numbers. You see? So they could land over here. In other words, you got the 17 there, right? It landed right there, see? And then this sequence here, the 17 double zeros, this is what you call a metamorphic number. It's an 8. In other words, the double zeros, this is like roulette. Roulette has double zeros, and that's equal to 8. So you could see like how it landed on 8 right there, see? See? So, but this combined, in other words, what you have is 178, right? 178. So in other words, this is equal to this, and this is equal to this. You see that? So that explains the concept of how these numbers, you know, these numbers are calendar dates and ticket numbers, right? And that has, even though these are all planned out way in the future, right? And then when the day comes, these spins happen, right? But they all link to these numbers. There's synchronicity between what we project in the future and what is the present. There's a relationship to that. So that's important to understand, or else you're not going to be getting these numbers. Once you understand that there is a relationship, then you start focusing on what these numbers are, you know. Whenever you get a 16, like right here, see, there's a 16 right there, and you're deciding what numbers are going to fall here, right? And so you got a 16. Now what 16 is equal to is the number 28 carries the statement 2 8s, right? 2 8s. What is 2 8s? 8 8, and 8 plus 8 is equal to 16. So if you're right here, you could assume that a 28 is going to form right here. See that 28 right there? So knowing that 16 is equal to 28, and you're over here, right? And you have to make a decision over here. One of the options is that you would play out at 28, so you can see how it landed on 28 right there. I'd like to talk about how we're analyzing this, how these numbers came about, right? So if you go over here, notice how what you want to do is you want to count the numbers of nines. 1, 2, 3, 4. So basically, 9. So what you have is 9 plus 9 is 18. Another 9 plus 9 is 18. So 18 plus 18 is equal to 36, right? So that's an important number. And so you have to decide, is it going to form a 36 or is it going to make an equivalent of 36? Now, if you go, notice that 16, right? One way to decide that is that if there's a 16 and it leaks to a 13, it makes a 36. So this is a very important sequence because you could see how, you know, it's playing out over here. If I could find it here, see, you got a 13, 16, and then I recreated it over here, 13, 16. That's all related to the 36, you see. So you count your nines. That's 1, 2, 3, 4. 4 times 9 is 36. So knowing that you're over here and you got a 16, it could create a 13. And so you can see how the numbers on the right hand side, that's 36. These are just statements. So this is basically like equals. The equals in mathematics, you know, equals, and that's basically 36. But the ones that have sequential potential is this. This is 36. This is equal to 36. So you got 4 nines. 4 times 9 is 36. And knowing you have a 16, now you know that that 16 links to a 13 to make 36. So that's why that theme played out. Because there's 4 9 9 9 9. 4 times 9 is 36, and so you got a 16 there. It's quite possible that if it doesn't play out at 36, it's going to play out at 36 like this way right here. And so, and why did that create a 42? Now, 42 was created because, see this 24 right here? Well, here, you see this number right here? These numbers are important. In other words, it could be looked at individually, or they could be looked at as two cells. So if you, by two cells, you got 40 on this side, right? And over here you got 2. So this is like 42. See? So this is important because if you're making a list and everything that's logical, you want to be able to write it down on a piece of paper just in case you want to reference what happens sequentially, right? So in other words, this number here, because we're dealing with this part, right? This is the sequence that you're trying to figure out. So you have to go and look at these and analyze these numbers, right? So notice how I did it. 40 right there, and this is 2, right? 1 plus 1 is 2, so it's 42. That's one reason. Now another thing, if you look over here, you see how you have that 24 right there, right? And then it links to this 13. This is the bridge number. So it's quite possible that it could reverse sequence itself right here. See? To fill this gap right here, 42. And because this is here, this gives you a hint that it is going to be 42. This is basically a reverse sequence of this this number here, see? So that explains all these numbers right here. The 13 was created because it creates 36, and because this is 9999. In other words, this is 18 plus 18, which is 36. So that, and having a 16 there. Now, remember I said that the 28 is equal to 16, right? That's another reason. 2 eighths is 8. 8 plus 8 is 16. And so you get this number here, right? And this number got recreated, right? So that's how it all worked out here. Here's the 17. You could even look at it separately. This is a 17 right here. Now this is a half step away, see? Right here? That's just a half step away, so that these numbers can affect this. This is your metamorphic number landed right there. This is your metamorphic 8, but this is what we actually in what I've explained how it actually happened here. So you have just won the lotto. I hope you enjoyed this. I'll be doing a lot more other ones, and again, this is the wonderful wheel of random sequencing. This is my email address, and so we'll see you on the next Super Lotto Plus sequences.